Okay, for this video, I will try to come across like different several important questions for kinetics, and then obviously in this kind of question has like actually come from different example, but then for A-level exam, actually the trend for the question is like getting harder and harder. Especially I have some like experience from teaching from like 2013. Therefore, I can actually see the trend of the question is getting more and more difficult. And more important is the question style is like changing and changing every year. Therefore, uh, if you aim very high, like aim A or A star even, then doing the past paper from the same example is obviously important. But then, other than from the same exam board, you also need to know some questions, some high quality question. Obviously, not every question. No one will have time to do all the question. So therefore, most of the time for my lesson, for my students, I will teach everyone, even they may not in that exam board, but then I will still pick something meaningful. I won't pick every question, obviously. Therefore, in for my like for my question booklet, I will pick all the high quality question, and obviously, according to different exam board, according to different minor knowledge that you learn, just like the last video that I said about something for half life, then I will do some adjustment for the question, but then just I will make sure that Alpha One, every students can see like all the high quality question uh, can do the best preparation for the exam. Then for this one, actually for this one, just like the important the important idea for this question is actually extracted from Edexcel. Therefore, even OCR or AQA or WJEC haven't asked for like this kind of style, but then just like what I said, they the the examiner may just extract some idea from different people, because like every year they want to do some changes, every year they want to make some new question, every year they want to like prevent those like smart students can easily gain a really high marks. Therefore, they will make some changes in every year. Okay, then we can go back for this question, and then we can see it's like, okay, a reaction of ketone and iodine under acidic condition to form a halogen alkane and HI. And then for this video, then obviously I will discuss the answer for every question, but then other than discuss the answer, I will also talk about some important information or some extra information behind the question. Okay, some extra content that you should know, or how you think the answer. Okay, then the first part in this table, in within a special part, is like they're using volume, because I think most of you guys have done some question about rate equation already. So maybe in your exercise, in your homework, you will see that the table most of the time will just having concentration of every substance. So in here is like quite specific or quite special, using the volume in the table. So here is represented you adding 20 cm cube and 60 and 10 cm cube. So not the concentration of H plus. And even I give you some concentration here. It's not the concentration in the mixture. It's just the concentration of the propanol, of the standard propanol that you have. Therefore, after the mixing, you can consider as like kind of diluting the propanol. The concentration will change and should be decreased to something. Obviously not 1 mole per dm cube. But then in here, why other than the using volume for the number, another special point is like they have water, and then you can see that you don't have any water, and then water is already a solvent for every chemical. So technically, you don't have to add extra amounts of water, and then water is not the reactant and also not the catalyst. Then why here you need to add water for every experiment? Then maybe at this point, for if you're kind of like good at number sense, then you may see that every experiment have a total amount of solution is like 100 cm cube. Yeah, when you're adding up, then you will see everyone has a total of 100. Then why? Then you may think like the first point of this one is like to make the total volume of solution become constant. Then you may think like why make a constant volume is like so important? Because if your volume is constant, and then if I need to really calculate the concentration, I mean for propanol in every experiment, or if I want to make the change in the propanol concentration, then what I have to do is just I need to adjust the volume. So what I mean is like from here to here, the amount of propanol is increased by 20, or you can say double. Therefore, if I can make sure that the total volume is 100 cm cube, and then if I double the volume of propanol that you add, then I can ensure one thing is like the concentration of the solution will proportional to the volume. Because you may think, in order to calculate the real concentration, I can do some simple math here, like using C1V1 and C2V2, because for dilution case. And in C1V1, you may think it's like 1 times 20 over 100. And then C2 times 100, because like total is 100 cm cube. And then for second experiment, I can set the equation like that. And then even we ignore the exact calculation first, but then we can see that the left hand side is double, then the right hand side must double. But then if your total volume is 100 cm cube all the time, then the C2, that means the final concentration of propanol, will also double. That means once you can ensure that the total volume here is 100 cm cube all the time, then you can ensure one thing is when we want change in the proportion, then the C2 will also change in the proportion. That means we can ensure that from experiment 1 to experiment 2, the concentration of propanol has doubled. That means we can using this hint to predict the order of reaction of propanol already. Therefore, here is also telling you like you may think when you do experiment, when you do a real experiment for kinetics in school, you need to change the volume of every solution because obviously you want to investigate the order of reaction. But then once you change the volume of the reactant that you add, you have to make sure that the total is 100 cm cube all the time. Or like some other number, obviously no, may not be 100 cm cube. Maybe you want to make it bigger, maybe 500 or something. That's also fine. But then make sure the total is constant, then will be more easy for you to do the calculation. Because you double the volume, then you can consider as like you double the concentration already. Yeah. Therefore, the importance of water is like including these 2 points. The total volume constant, then everyone the concentration will be proportional to the volume that you add. Yeah. Therefore, here will be the idea of part A. And then for part B, then obviously once we know that the volume can be considered as like concentration, then what you have to do will be similar to the normal question. Just like just like what I said, for propanol, then you can compare 1 to 2, then the con is double, then the rate is also double. That means propanol will be first order, as the change in concentration and rate is like proportional, which is like both double. Then iodine and propanol, then obviously the remaining will be iodine and H plus, and obviously we will ignore the water because they're not a reactant, so no one will be concerned about the order of water. Therefore, second one, then we can consider H plus first, because when we compare 1 and 4, then only H plus is changed. Then we can find the grade. It's also double when you compare 1 to 4. So H plus will be another first order. because here is like double and rate is also double. Okay, then obviously the last one will be iodine. But then for iodine, it's also kind of like a tricky case in terms of math, because you can see no matter which two experiments you try to compare, every comparison other than I2 will change, you will see another change. What I mean is like no matter you talk about 1, 3, or 2, 3, or 3 and 4, other than changing iodine, you will have another change. Therefore, technically, like you can just pick any random one. So maybe I pick 3 and 4. Then here is like double, and here is like half. But then from here, what we already know as like order of propanol is first order. Therefore, the effect of changing the concentration of propanol, it should be double in rate because they're first order. But then you can see that at the same time the iodine is changed, right? Iodine half in volume, so half in concentration. But then based on the result for reaction rate, you can't see any effect from iodine. That means the change of iodine is not relevant in this case. That means iodine is like zero order. Therefore, the rate expression we can write down like that. Remember, for most of the question, they will ask you to write down a rate expression, write down a rate equation. Therefore, other than calculate the order, make sure you write down a final formula for the rate equation. And if they're first order, so no need to write a 1, is also fine. So here will be for part B. And for part C, then they want you to calculate the rate constant and also the unit. So solving rate constant should be an easy one, because just rate is already this number. They ask you to using the data for experiment 1. So to solve K, then obviously we just need to know the concentration of the ions of the propanol and H+. But then that will be an important question already to solve the concentration, because we can't just using the 1 and 1 here. Remember what I just said in the first point? 1 mole per dm cube is the concentration of the sample solution. It's not the concentration of H+ of the propanol in the mixture. Therefore, we have to do something to solve the concentration in the mixture. Then obviously the solving won't be very difficult, but then just you have to realize that you have to do a solving. You can't just put in a 1, because 1 is the con of the sample, not the con in the mixture. So we can just do something for C1 V1, and then the V2 is 100. Then we can solve that for C2, and then C2 should be 0.2 for propanol. So we know the first concentration, and then we can do something similar for H+, which is 1 times 10 over 1000, and then C2, and then 100 over 1000. Therefore, the C2 for H+, it should be equal to 0.1. Yeah. Therefore, obviously I can solve the equation like that. Just over by 0.2 and also 0.1. Then for the unit, now I think if you see second order reaction, then maybe some of you guys can like remember the unit already. I mean the unit of constant. But then other than memorization, you can do some solving. And then the solving, I want you to think in some other way. Because in here, we know that K is like rate over concentration. And then unit of rate is already mole per dm cube per second. But other than mole per dm cube per second, you can write in another format, which is concentration per second. And here is like second order. So actually we can consider as like concentration square. Then it become concentration to the -1 and second -1. Then we can expand the unit at this point. What I mean is like expand the mole per dm cube at this point. Then you will have mole -1, dm +3, and s -1. Then obviously this unit will be like same as the one that I gave you in NOC before, or same as like what you can memorize. from maybe your teacher notes from your textbook. But then just something if you can solve, then technically you don't need to memorize. Because in chemistry, so many things you have to memorize already. So once you know how to solve, then you can save your like time to do some like memorizing. And then when you solve, you can solve in this way instead of just okay break down all the thing at the first point like concentration square. Then maybe your teacher in your school may teach you okay expand the bracket first. Then you have more square and then dm minus 6, and then combine this one with the unit of rate and then do the cancel out like that. Then obviously you will get the same answer. But then just in math, when you're doing less algebra, then most of the time the accuracy should be increasing. Yeah, because just sometimes maybe you will get some like easy mistake for doing some simple subtraction. Yeah, so you think here's like kind of a alternative for doing the unit of rate constant. Okay, then we'll move on to the another question. Then this one will be a graph analyze. And then for this one, you think like specific for example other than AQA, because for OCR and Edexcel and also WJEC, then you have to using concentration time graph to predict the order reaction. But then for AQA, I would say like most of time, at least like only the new syllabus have asked you to using Raycon graph only. So you may ignore the concentration time graph first. At least like you're not requiring to using half-life to solve. Because as here, obviously as a curve, then the only choice of the order reaction must be first and second order. Then to distinguish between first and second order, the only way is like using half-life. Find the half-life and then try to determine whenever they're constant. Therefore, we can really do the counting like that, 0.8, and then to here, and then to here. Then we can determine the first half-life here, which is 50 seconds. And then from 0.4 to 0.2, then it's 100. But then remember the half-life is counting from 50 to 100. So that means the second one is also 50 seconds. Then obviously counting half-life you can start from any point and then end with any point is also fine. Like 0.3 to 0.15 is also fine. Then you should get a 50 also. Yeah. But then just once you count for half-life, once you count successive half-life, and then you see that they give you a constant value, then you can say the first and second half-life are both 50 seconds. So that means they have a constant half-life. Therefore, there will be a first order of a reaction. And then for B, there will be like different way to do it if you're like studying different example. Because just like what I said, for people who doing OCR, then you should know the equation, because this one for first order reaction only. And then we know the half-life is already 50 seconds. Then we can do a solving like that. Then means the K will be equal to ln2 over 50. So for OCR students, you can do a easy solving like that. But for Edexcel or WJEC, then you don't have this one. That means you can't solve like that. So that means you still have to using a normal way, which is like found the concentration and found the rate of reaction. Then if you have a current time graph, then obviously to solve the rate of reaction, the only way is draw a tangent and then find the slope of tangent. But then you may think, okay, here I have so many data points, then how do I know which point I should use for rate of reaction? Then technically like you can use in everyone. Because once maybe I'm using this one, then the corresponding con is 0.4. If I'm using this one, then the corresponding con is 0.1. Therefore, just the only thing that you have to make sure that is like, if you're using rate at 0.1 concentration, then you will put A at 0.1. If you want to find the rate of the tangent from the tangent at maybe 0.3 concentration, then you put in A as 0.3. Therefore, for drawing a line, then you can draw a tangent at any point, but then just make sure that you're using the concentration at that point. Then technically you should solve some number that's similar. I can't say 100% the same, because obviously when you draw a line there should be some kind of like slightly difference, slight error, small error. But then if they ask you in terms of determining slope and then using a slope to do some calculation, then in the mark scheme the answer will allow some like variation, will allow some range. Therefore, yeah, just don't need to worry, but then make sure that you're using the rate and concentration for the same number. Yeah. Okay, then we'll move on to another one. And then this one, I would say this one is kind of a kind of a tricky question, because you may think every year they may ask you something like kind of random, kind of outside the box, which is not finding in textbooks. And then here you can see that they give you some information for zero order reaction, which is they told you half-life. But then technically this one is not required in all level, in all level exam. No one have to know the equation for this one. So technically they won't expect you to know. That means they won't expect you to using this knowledge. So in here, just based on I give you the equation already, and then remember here the concentration knot here is representing a con at the start point of any half-life. So that means if you have a graph like that for zero order, it should be like this. Concentration time graph, it should be a straight line downward sloping, and then you may think the Z knot here can be here, can be here, can be here, can be here. But then you may think like from as the reaction happen, then as the line, like when you move to the right hand side, then the con must decrease, right? That means this value must decrease as the reaction process. That means once this value decrease, then you already can able to deduce the half-life must decrease, because the K is very constant, which is a constant throughout the whole experiment. Therefore, we can easily extract the answer here. Yeah. So you think for every year, every paper, there may be some correction as like kind of requiring to do some logical deduction at the exam. It may not require you to using some difficult knowledge, because you can see that all the thing here, the only point that you know is that the line, the graph for zero order reaction, and then the knowledge of like decreasing the number at the left hand side, then the right hand side number is also decreasing. So actually the knowledge they need to know is easy stuff, but then just you have to kind of make an application from what you have learned. There will be like an important change in the new syllabus, because I would say from the old syllabus, which is like the last one is like 2016, to the new one, other than okay they modify some content and so syllabus, the important part is like they have made more and more correction in kind of a random way, in kind of a logical way than you think. Therefore, other than just memorizing or like know everything else in the syllabus, you also have to prepare yourself to think it logically in the exam. Even you see something randomly, but it just no need to like think so many random stuff, or think that okay you haven't learned, then why you can solve that. Just calm down and then think logically, then you still can solve it. Yeah. So here will be the end of this video. So maybe next time we can talk about something for like organic chemistry, or maybe some other topic. But then obviously in my video, other than the basic knowledge, the basic concept for every topic, I will also focus on the solving techniques for every question, for every special questions. Yeah. So this is the end for today.